5-axis alignment curves for along curve machining. An along curve machining strategy is now included in the 5-axis module. The strategy allows a curve to be machined with either the tool axis normal to the drive surfaces or to force the tool to follow a set of tool axis alignment curves. An earlier video demonstrated both methods, but used curves provided by the CAD system. Here I will show you how curves can be extracted from existing surface model edges to machine along, and how to create alignment curves to use for the additional control of the tool axis. As with all 5-axis machining, the model file needs to be loaded through the Granite Reader. Also, the face orientation for the surfaces must be checked to ensure the correct direction. Let's open the model file, remembering to tick the option to use the Granite Reader. Set any necessary fields in the project settings and click OK. To keep the contents directory tree view tidy, let's remove any surplus folders. Let's inspect the surfaces. Select the triangulated surfaces, and from the View menu, check Face Orientation. This is to ensure the surfaces are all the correct way round. The default colours are blue for the front face and red for the back face. We would hope only to see blue faces, as in this case. If any faces are showing red, then these will need to be reversed. To suppress the face orientation function, visit the View menu, Face Orientation listing again. We need to create separate folders containing the drive surfaces and the check surfaces. Select the front part of the yellow surface. Right mouse click to display the menu. Hold down the Control key and choose Label Geometry. This will create the Drive Triangulated Surfaces folder. Ensure the surface is still selected. Right mouse click to display the menu. Choose Invert Selection. Right mouse click again to display the menu. Hold down the Shift key and choose Label Geometry. This will create the Check Triangulated Surfaces folder. We now need to create some curves from the existing surface model edges and arrange them in separate folders. Ensure only the Drive Triangulated Surfaces are selected and visible. Select the required surface and from the Curves menu choose Extract Converted Curves. Uncheck the option to join curves. This will create a folder called Edited Triangulated Curves. Open the folder and inspect the contents of the tessellations list. In this example, there are 3 curves. Select and delete the 2 curves at the top. The folder name is now Edited Extracted Triangulated Curves. Rename this to Profile Curves 1. Now create the additional vector curves to guide the tool axis. In this example, they are created from points. Set the geometry to a top view. From the Points drop-down menu, choose Create New Points folder. In the graphics window, double-click along the curve at the location of the first point. This will enter the coordinates into the tessellations list in Editable Points 1. To add the second point, again, double-click at the XY location required. We may need to make an edit to the Z value to achieve the required result. From the Points menu, choose Points Editor. Highlight and edit the Z value for the second point. Select the Editable Points 1 folder, then from the Curves menu, choose Convert to Curves. This will connect the 2 points as a straight line, giving us the vector we require. I am now going to use the same principle to create 3 more alignment vectors. I'm going to lift the Z value here to exaggerate the curve movement for the demonstration. Make this one lower. We should now confirm the direction of the curves using the function from the View menu, Curves, Direction Arrows. Note, they must point away from the surface, otherwise the system will attempt to machine from the other direction. If there is a need to reverse the direction, select the curves and from the Curves menu, select Reverse Curves. Suppress the arrows by revisiting the View menu. Now select the 4 triangulated curves folders. Right mouse to bring up the context sensitive menu and choose Combine Folders. Rename the folder AlignmentCurves 1. For this example, we are going to select the drive surfaces, the profile curves, and the alignment curves. With the Alignment Curves folder also selected, the tool axis will be forced to align through the vectors contained within the folders. The folders must be selected in this order to achieve the correct cutting and guidance strategy. Right mouse and choose 5-axis along curve. Select a suitable cutter. A quick check of the passes page. Here we can ensure we are tilting through lines. Click OK. Animate the toolpath to confirm the correct operation. Here we can see the tool axis now being forced through our alignment curves. For this example they've been exaggerated, but this demonstrates the procedure.